presently using some UF4007 Fast Recovery Diodes going into the cell, going out of the cell with current respective, and a loop back from the negative to the positive. And if you recall some of my waveforms from previously, you can see the recovery time during the pulse off is fantastic. It was dipping down here close to zero and even further, and that is wonderful because that allows more voltage potential in the cell. Here in flyback mode, we get beautiful equal opposite polarity pulse on that collapse. Look at that. In this particular thing, I've changed out, swapped out this diode I normally use for this Fast Recovery Diode 2 amp 1000 volt. This is essentially on this loop of the circuit, where the inductor is also connected up. Current respectively, though, the diode is pointing that direction. Interestingly enough, and through the diodes I've recently connected in and out of the cell and the one loop back or feedback, we get voltages up to 110 and nice equal opposite polarity. Pause that. Consuming almost 6 amps, less than 1 amps at the cell. You can verify this by these diodes here that get just the tiniest bit warm. These are rated for 1 amp. These will blow up over 1 amp. So if I was going over 1 amp, these things would be getting extremely hot. I would not be able to touch them, and they would eventually blow. But given that my amp meter says I'm 800 milliamps, I'm within that threshold, so they do get warm appropriately. But that more or less confirms that, you know, the amperage I'm pushing through here is what this amperage is reading. Because if this was off, if it was actually like 2 amps, 5 amps, whatever, those little diodes would be exploding. This equal opposite polarity I'm obsessed with. Obviously, this is during that pulse on time. We're able to extend that pulse frequency out to 75% and get some pretty impressive production at the cell. So that amount of gas being produced will be sufficient to feed into a gas resonant chamber. Welcome to Season 5 of Stan's Revenge. My name is Noah Alman. I've uncovered the true fundamentals of the electrical polarization process. This is unlike traditional DC electrolysis, as the dissociation of the water molecule is performed by opposing voltage potential instead of amperage. This allows for the generation of HHO gas from natural water without any electrolyte or chemical additives. In this chapter, I experiment with new cell designs, VIC transformers, and the electron extraction circuit. I'll be improving water fuel cell efficiency and increasing gas production to even greater levels. Join me as I uncover the secrets of Stanley A. Meyer. This is Stan's Revenge. Pay attention here to the reference ground here, which is basically that free floating ground we have here. We have nearly equal opposite polarity. We have just a little bit more negative potential than we do positive potential, so I'm assuming we need to maybe reduce a handful of windings on that inductor, on the negative inductor, and see if that will maybe help balance this equation out. We want that to be as near as possible. I theorized that when you have equal and opposite polarity pulses, or energy rather, built up in the cells, it prevents amp flow. It helps prevent amp flow because when there's an offset, there's more negative than positive potential. So you have some leakage in that when it is not perfectly equal. If it feels perfectly equal, the forces would be equal opposite of each other and would not allow current or amperage to pass through. In this case, since it is off a little bit, we have more to balance it out. I had to add more windings to it. So bypassing the essential additional windings that I did here brings us closer to true equal opposite polarity. Now see, it's almost a little bit different where there's just a little bit more positive potential than negative potential. 100 volts at the cell, 3 amps consumed. Look, check this out, 3.3 amps and 600 milliamps. We have basically 100 volts at the cell. Removing that tap again gives us somewhat equal but more negative potential this time. We do have a little bit higher voltage. Look at that amp difference though. Like, wow, we have 200 more milliamps at the cell, given the increased voltage. But we have 6 amps almost, as compared to 3 point something that we were previously, just based on changing that inductor. Now hold up. Tapping that off again, we can see the difference in polarity values. We have just slightly higher positive, but 3.2 amps. We're only 10 volts off of where we were. So a jump from 3 to 7 amps is considerable just for a 10 volt negligible difference in the cell. 600 milliamps at the cell compared to, what is it, 800. Reasonable, but crazy amp savings by just changing the value of that inductor. Now that's really interesting. So maybe we get the higher voltage from the obviously more windings of the inductor, but it becomes off balance because this is more than the secondary's coil. Therefore, maybe we need to add additional windings to that secondary, or just, more windings to that inductor to balance that. Hold up. I just discovered my safety ground is not working. That should be 0 volts when this is off, because it should automatically ground. Danger zone. We might have an opposite effect here. That green is almost dipping down halfway in that square now, so hang on. We're also at 110 volts and 6.7 amps input. Well, looky there. Look at that imbalance now. We were, clearly down to there in this last video, if I am not mistaken. But you see, we're right on that line right there, that cube or square. So maybe it's like the opposite effect of what I was dealing with, like the balancing of inductors or waveform and all that in a previous video. Maybe I'll reference it, but because there's too much negative polarity, let's say, I need to wrap more coils to this negative coil to balance it. Digging in my box. There's only one way to find out. You know what? I have just the wire for this. My scrappies. Fire! 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 Alright, added a number of more wires here. Let's see what happens. And we still have that offset there, unbalanced. Holding steady at 112 volts. Still just under an amp. Pulling 675 amps total, but yeah, we definitely have opposite polarity on the plates. No doubt these things are producing, and my needle's starting to bump there. Yeah, look at this with the primary polarity switched up though. We're voltage potential, that's 50 volts right there, but during the off time we have this wonderful, very much spiky, equal opposite polarity, like spiking. Look at that. You can see we're still a little off as far as equal opposite, but we are both at 2. Yep. Very interesting. 90 volts almost. Matter of fact, I've been reading this wrong. This is our 0 point line, so we have 1, 2. This is about 2.5 cubes, whereas this is 1, 2, 3, nearly 4 cubes now. Look, we have added inductance to it. See? So in reality, we have way more inductance on that than we need. We need inductance on the secondary, essentially. The oh wait, hang on, wait, whoa. Got it pretty much balanced right here, I feel. That's pretty close, I'd say. Got up to 110 volts. My phone's about to die. 6.5 amps. But yeah, cells are just puking. Getting some air movement. Definitely getting gas production.
This is Stan's Revenge.